Speaking of suits, our next speaker, Jose Sanchez, is going to be talking about the xEMU update for extravehicular mobility unit overview and status. Over to you, Jose.
Hello, everyone. Hope everybody's enjoying the various presentations. So as mentioned, I'll be covering the latest status on the Exploration Extravehicular Mobility Unit, or xEMU. Next slide, please. So I intend to kind of go over just kind of a high-level overview of it, and then I'll step through each of the subsystems to give a little bit more details. Next slide, please. So first off, I did want to bring everybody's attention to the NASA SUDA page. If you haven't seen it before, this is a page where the team uploads information of what's going on with xEMU. This image in particular highlights some of the features of the xEMU, so definitely recommend to check it out. And so I'll be covering a couple of these items. Next slide. So the xEMU is being developed to allow the crew members to conduct excursions outside of a vehicle, whether that is Gateway, ISS, or HLS, to perform exploration, science research, construction, and repair operations. So some of the key capabilities are being able to perform up to 8-hour EVAs, as well as perform up to 2 hours in permanently shadowed regions, and then just in general being able to perform some of the tasks either standing or kneeling, such as the sample collection, as well as translating up to 2 kilometers away from the lander. And then also we will be having improved lighting and cameras. Next slide, please. So the xEMU system is comprised of 3 subsystems, and that is the Portable Life Support System, or XPLIS, the Pressure Garment Subsystem, and then the Informatics Subsystem. And I'll be going into each one a little bit more here in the next slides. Next slide, please. So the Portable Life Support System, that's if you look here on the left, the red backpack, so that actually has the oxygen storage, which is providing oxygen for the crew member as well as for pressurization of the PGS. Also the ventilation loop, the thermal control loop, the power source or the batteries, and then the caution and warning system, which is the monitoring system for the BLIS. And then also you have the display and control unit, which is on the right, located on the chest of the crew member, and that is where the crew member will be inputting functions for the various items in the BLIS. And then also just highlighting the pressure relief valves that are located on each of the sides of the crew member to maintain the pressurized environment. Next slide. So as far as BLIS progress, the preliminary design is complete, and the team has been focused on completing the component level design verification. And then after that, the next stage is to continue assembly of that DVT unit. And so you'll hear me mention DVT and some of the other subsystems, or all of the other subsystems as well, as they're each undergoing that component level, sub-assembly level testing, and they'll be continuously combined and integrated for the final DVT unit. So the BLIS testing does consist of 43 different tests that are planned to verify the different life support functions, as well as we'll be performing 6 simulated 8-hour EVAs with human metabolic gas injection, as well as thermal loop heat injection to verify the system in the vacuum environment. Next slide. So another image from the SUDA page that I wanted to highlight is of SURFE, and I know it's been mentioned before, but so this is the Spacesuit Evaporation Rejection Flight Experiment. And this is actually a test of the BLIS thermal loop system on ISS. It was launched here in October of 2020, and it is installed in the ISS payload rack. It consists of 6 EVA series, each simulating 45 EVAs at a time. We're about halfway done with this test series. Now, we also do have a ground unit being tested, and the intent there is to compare performance between the two, the one on ISS, the one on the ground, and learn as much as we can from that test data as we then finalize the BLIS design and incorporate that into xEMU. Next slide, please. So the next subsystem, the pressure garment subsystem, some of the features on it is it will have improved mobility with the design being influenced by all the experience we've gained on EMU, as well as it'll be designed to accommodate 90% of the female and male population. and we'll have an integrated communication system. So this is different from EMU in that EMU has what some folks know as the Snoopy cap with the comm system integrated into it. And this one is actually a part of the suit. And so it is divided into sections like the upper torso assembly, which is comprised of the visor, the helmet, shoulders, gloves, and then the lower torso assembly, which is like the waist, the legs, and the boot assembly. And does also contain some of the equipment such as the liquid cooling and ventilation garment used to maintain the crew member's temperature, as well as the wired heart rate monitor. Next slide, please. The BGS team is hard at work, and not only do they have to ensure that we maintain the crew member in a safe, pressurized environment, they also have to ensure that the suit has the ability to perform the various science tasks that we've been discussing. And so, obviously, being able to collect the various samples, as well as using the EVA tools to remove rock from larger pieces of rock, or just being able to traverse the lunar surface. And then just a couple of images from some of the testing going on in the neutral buoyancy lab, testing out the different functionality wearing the suit. Next slide. So some additional pictures. So the PGS team has performed numerous different fit checks and evaluations. If you look here on the left, they're testing out the crew member's reach in the suit, as well as their ability to use some of the EVA tools here. And then on the right, you'll actually see something I think is pretty impressive, is being able to, this is a pressurized suit. And so as they step onto this red block, just showing some of the flexibility of the new suit. Next slide, please. So the xEMU system is focused on electronics that will help the crew member be more efficient and more autonomous during the spacewalk, and provides data to mission control and to the rest of the team. And it is comprised of the informatic lights, the camera, the Wi-Fi antenna, as well as the informatics processor. So if you look at the image here on the right, you will see the four lights at the top of the helmet. So two on the side are the task lights that are more focused in the envelope closest to the crew member. And then you see the two top lights, more the translational lights. And their intention is to help with that situational awareness as the crew member is walking on the surface. Another thing to highlight, so recently the EMU camera has been updated to the HD EMU camera assembly, or HECA, and it is providing the capability to stream the 1080p video. And so the team that worked on it is also working on the xEMU camera. So I'm sure a lot of the lessons learned will go into that final design. Next slide, please. So here are a couple of images to show kind of some of the challenges with regards to lighting. So during the Apollo program, the landing site obviously had a lot more lighting than what we're expecting. And even then we saw some of the challenge there, and you can see on some of the shadows. But then if you look at the image I'm showing here in the bottom, this is a VR simulated view of lighting on the lunar South Pole. As you can see, that really is going to stress our capabilities, and we need to make sure that the lighting system is ready to do the job. Next slide, please. So on the xEMU lights, initially the team did intend to use the EMU lights, but after various assessments and evaluations, it was determined that going to a new lighting system was the right way to go. And so here's after various iterations, here's the image on the right showing some of those components the team has come up with. Next slide, please. And so this is another picture similar to what Adam was just sharing of the xEMU team and the tools team out in the rock yard. And so this is just a way for us to kind of get a sense. This one is actually using representative lighting, but to get a sense of what capability we will have. And so the next plan is for us to bring the xEMU DVT lights out there and see how they perform. So next slide. So as far as forward path, The team recently completed the PDR, or the preliminary design review, here in December of 2020. And then we'll continue on the DVT testing for the rest of the subsystem, or for all the subsystems, followed by a critical design review in 2022. And then a demonstration of the xEMU on ISS, and then continuing support on ISS, and then finally continue development with the HLS and the US industry for the lunar surface missions. Next slide. And I think that is one last picture of the hard upper torso. Thank you very much.
Thank you very much, Jose. It's great to see the progress on those suits and the extra flexibility that's being built in. We need that flexibility to grab our rocks from the lunar surface.